Hi guys, today I'm going to be doing the worked examples from 3.6. So this is inverse graphs and relations, and of course it's from our jacplus textbook, year 12. So it shouldn't take too long actually, because we did inverse in year 11, and also there's only 2 worked examples, and I think they're pretty straightforward. So they're asking us to sketch this graph, and it's a parabola, and look, you probably don't need to write the list of features here: shape, y-intercept, x-intercepts, and turning point. So you probably can do that effectively without a little list, but I'll do it just for the sake of completeness. So the shape, it's a positive graph. So there's it's not a negative x squared, so it's going to be the U shape. The y-intercept, well, if we're subbing zeros into those x's, they're going to disappear, and we're going to be left with -3. So 0, -3 is our y-intercept. X-intercepts, looks like it's a fairly straightforward one. Let's cross-multiply that. Of course, y equals 0 for the x-intercept. X times x and -3 times 1. So 1x minus 3x equals -2x. Yes, that's the middle term. So in the brackets goes x minus 3 and x plus 1 equals 0. So that would mean x equals 3 and x equals -1. So we have x-intercepts at 3 and at -1. So the last feature is, of course, the turning point, and the best way we can find the turning point here is knowing that the x value of the turning point is in the middle of the 2 x-intercepts. So we'll do that. So x value of the turning point is going to be, well, we can take the average, 3 plus -1 over 2. So 3 minus 1 is 2. Equals 1. So that's the x value. So of course, for a turning point, we need an x value and a y value. So to get that y value, of course, we're just going to sub that 1 into our original equation. So y equals 1 squared minus 2 times 1 minus 3. And that is 1 minus 2 minus 3. 1 minus 2 is -1. -1 minus 3 is -4. So our turning point is at 1, -4. So they're asking us to sketch that, so we've got all the information we require. I will sketch that. So our turning point at 1, -4, I'll pop that here. And the x-intercepts at 3 and -1, 0. Notice how I'm putting all my important features in coordinates. The question is never going to say don't do coordinates, but it may well say do coordinates. So if you just always do coordinates, you're never going to be wrong. So the y-intercept at -3, so it'll go something like this. And that's at 0, -3, again as a coordinate. So there are all our important features on that parabola. So we've done the first part of sketching it, and that's really not the inverse part. The inverse part comes next in part B. They're telling us on the same set of axes, sketch the graph of the inverse. And inverse is the opposite function. So everything's opposite about it. And, you know, I'm going to use orange because I'm pretty sure orange is the opposite to purple. So we will use orange. So on the same set of axes, sketch the graph of the inverse. Okay, so all we need to do here, we don't need to find a rule or anything. They're not asking us to do that. So we're going to say this is y points, and this is going to be the y -1 points. So to indicate an inverse function or relation, we will put to the power of -1. So let's see, our point for y here was -1, 0. We had another one at 0, -3. We had another one at 1, -4. And our final one was at 3, 0. So all you need to do, and you see the table is quite handy here, you just need to swap them around. 0, -1, -3, 0. Your x's become y's and your y's become x's. So this is the same if you have an asymptote. If it's an x-asymptote, it becomes a y-asymptote. Any point is just swapped around. An x-intercept becomes a y-intercept, and a y-intercept becomes an x-intercept, which actually we see this x-intercept is becoming a y-intercept. And this y-intercept is becoming an x-intercept. So we've got more than enough features here, more than enough points to draw our inverse function really quite nicely. So let's see. 0, -1, I'll put that on. 0, -1 will be around about there. The next one, -3, 0. So here. -4, 1, maybe there. And 0, 3, maybe here. And then we can just connect them up. So it will be something like that, with all those points marked on. And you can see it's like a sideways parabola there. So we'll talk more in the next exercise about how it crosses over the line y equals x, and we'll talk more about the intersection of the inverse with the original function. But for now, that's all they're asking us to do. So the important thing here is that you were able to swap the points around and draw the inverse graph there. So let's have a look that we've done. So I think there's another bit to this actually. Oh, I'm pretty sure there was a part C, and yes, there is a part C, and part C is asking us to state whether the inverse and the original y is a function or not, and its correspondence. So for part C, we've got the parabola, and the parabola is a function. And how do we know it's a function? Because, well, if we put a vertical line, it's going to pass the vertical line test. So anywhere we put a vertical line, it's only going to cut the parabola once. So that tells us it's a function. For the orange one, our inverse there, well, the inverse is not a function. And, well, we can see that because if you do the same thing, and I probably shouldn't have rubbed them out, anywhere I cut, well, already I've got two places, there and there. So already it's cutting our graph twice, so it can't be a function. So it's not a function. Now, they also ask us in this part for the correspondence, and our parabola is many to one. And they put the little dots there. And what that means is we have many x values for one y value. So I can interpret that in that way. There's many x values for just one y value, and I'll just show you what I mean. People often don't understand that. So if you have a y value, let's say the y value is 2. Well, we have one y value, but then two x values that give that. So there's a negative value over here and a positive value over here, both of which give you the same y value. So you have many x, in this case only 2, but we call it many, and to one y value. So that's many to 1. And for our inverse, well, without even looking at it, I know it's going to be 1 to many because it's an inverse, so it's got to be swapped over. But if I look at the function, what this means, I have one x value for many y values. And this is a little bit easier to see because, well, I think so anyway. If you have one x value, let's say that's a 1, then that's one x value gives rise to 2 y values. So it's one x value to many y values. So that's how we label those. Part D, which I also for some reason haven't put on the page, so that asks us for the domain and range of the original function, the parabola, and its inverse. So domain and range, and then the inverse, domain and range. So let's go back and have a look. So the parabola, the domain is R, and the range is from -4 to infinity. So let's write those in. Oops, wrong one, and negative 4 to infinity. And well, let's look for the inverse. So the inverse, we see, well, the domain is negative 4 to infinity now. So we're going from negative 4 to infinity, and the range is going to be r, because these ones, although they look pretty flat, they're actually continuing forever. So let's write that down. So the domain is neg 4 to infinity, and the range is r. And what you might notice here is that, well, or you might remember from last year, is that the range of the original becomes the domain of the inverse, and well, vice versa, because the domain of the original becomes the range, and the range of the original becomes the domain of the inverse. So they swap. Just like the points, the x and y points swap, the domain and range swap because they're related to x and y. So that completes the first example. Let's move to the next one. And look, something important to note is that only a one-to-one function will have an inverse that is also a function. So we saw that just a second ago. We saw that the orange inverse there was not a function. And that's going to happen if your original is not a one-to-one function, then your inverse will not be a function. So this is important. Only a one-to-one function will have an inverse that is also a function. So let's see up here in worked example 10. So consider the graph that we've just drawn. The domain is restricted to this value here from negative infinity to a, where a is the largest possible value so that the inverse function exists. So we know for the inverse to exist, y must be a one-to-one function. And I should be careful there, for the inverse function to exist, because we saw we can get an inverse, but it's not a function. So now let's redraw that parabola just for the sake that we can see a little better. What was it? Negative 4, something like this. So this turning point here was 1 and neg 4. Let's double check that. Yes, 1 and negative 4. So now if we want to make this a one-to-one function, we're going to have to cut it. And the place where we can cut it is on the turning point. So for a parabola, the turning point is where we'd cut it to make it a one-to-one function. You could cut it here if you wanted to, because, well, you'd also have a one-to-one function if you did go from negative infinity up to here. That would be fine as well. But what we want is the largest value of a. They've specifically asked. So that means at this point here, at the turning point, you're going to have a one-to-one function for this part. So from negative infinity up to our turning point, if we cut off all that, it's now a one-to-one function. So that means the a value, so the domain has to be from negative infinity up to 1. Because at 1, if you go more than 1, so just say we go to 2, let's pretend 2's there. If we add that on, then this is no longer a one-to-one function. We're cutting it twice. So that means a equals 1. So that would be the first bit. Sketch the restricted graph of y and its inverse on the same set of axes. Okay, so I'll move down a bit. So the restricted graph, we've already got it up there, but I'll draw it again. And I'll put in these points. So 1, neg 4, I think it was negative 3, but I'll just double check. Negative 3 and negative 1, okay. And what was it? Negative 1. Okay, so they were the 3 points that we had, which were that side of the function when we restrict it. So now they want us to do the inverse function on the same graph. And the point is that our inverse function is still going to have the opposite points. So our original, so our y function has neg 1, 0, 0, neg 3, and 1, 4. And you don't need to write it again. You could just put them on. I just want to make it a bit clearer. And then so the inverse is going to be 0, neg 1. So let's put that on. 0, neg 1, put that one there. And 0, negative 3 becomes neg 3, 0. And then 1, 4 would become 4, 1. Oh, hold on, 1, negative 4, no wonder, would become negative 4, 1. So negative 4, 1, that's better. And what we see is we've only now got this part of the graph. And this is a mirror image to our original function. It's a mirror image across the line y equals x, and we'll talk about that more as it comes up. For the moment, the important thing is that you can swap the x and y values around, and that you know how to restrict your domain so that you get a one-to-one function, because without a one-to-one function, the inverse function will not exist. So be clear that the inverse function doesn't exist. You can still make an inverse, but it's not a function. So let's see what they give us here. So we've done that. Part C, give the domain and range of both graphs. All right, let's have a look. So the domain of our original graph of y is going to, actually, let's just do it like this. So for y, the domain equals from negative infinity to 1. That's our a value that we worked out. And the range is going to be from negative 4 to infinity. For our inverse, so y neg 1, well, that's going to have a domain of neg 4 to infinity. So you can see it's going from negative 4 to infinity, and it's going to have a range of, well, negative infinity to 1. And if you didn't sort of notice, or you couldn't work it out, if it was a difficult one to work out your domain and range, it doesn't matter, because they just swap. The domain and range swap for the inverse. So we can see that they've swapped over there. So you really don't even need to look at the inverse in order to find the domain and range. You can just assume, and you'll be correct in assuming, that it's the opposite of the y function. All right, so that completes the two examples, the two worked examples.